Welcome back. Problem number 2340. Minimum adjusted swap to make a valid array. So you are given a zero indexed array, integer array called nums. We should have a swap of adjacent elements are able to be performed on nums. And a valid array meets the following conditions when there are two conditions. The first one is that the largest element is in the rightmost position in the array, and the smallest element is the leftmost position in the array. We should return the minimum swaps required to make nums a valid array. So if we look at this one as an example, we have minimum 6 swaps to make this as a valid array. So we have 5 here and 5. We need to have, I guess, 2 swaps, and we have 1. And in terms of 1, we have to about like 6 swap or something like that. So and we can change this by this, and it will be mostly 6. So you can look at this as example. We have here 3 was 5 and 1 with, and after that we have 3 5 and 1 was 5, 3 was 1, 5 with 1, 4 with 1, 3 with 1, and we have 1 and 5, and that's it. So let's understand the problem first. The task is to rearrange the array such that the smallest element in the array is the leftmost position, and the largest element in the array is at the rightmost position. And also we can only swap adjacent elements, and we need to minimize the number of swaps. So we can solve this problem in 2 steps. The first step is to finding the smallest and the largest element. Like if we try, let me take this as example here. Let me try to reload. No. Okay, let's take this as an example. And okay, great. So here we need to calculate, or we need to find the largest element and the smallest element. In this one, this is the largest and this is the smallest. So after we find it, we need to find where the elements, where are these elements. After that, we should calculate the number of swaps. How we would do that? So we count how many swaps are needed to move the smallest element to the front. So we should need to calculate how many elements is needed to move this smallest element to the front. Also, we count how many steps are needed to move the largest element to the end. So we have this one, we need to count this. However, if the position of the smallest element is to the right of the largest element, moving them affects each other. So in this case, we save only one swap. For example, we have this one with this smallest one is at the rightmost position. So basically, moving one to here, it will affect this element. So we don't need to calculate the number of swaps of 1 and 5. We only can take 5. We can only take the swaps of 1. So how we can do that? Let's jump to the code. Here in the code, we try to first create some variables. I want to create a constant called in, and this will be nums.length. And we will have 2 variables. I will call one min index, which will equal 0, and I will have another one called max index, which will always also equal 0. And we try to identify, like we need to find the index of the first occurrence of the minimum element. So how we do that? We create a for loop, and we say let I equals 0, I less than n, I plus plus. And I would say if nums of I is less than nums of min index. If that was the case, that means we have another small an item or a variable or an integer which is smaller than the number at the min index. So we update the min index to equals I. Okay, and after that we will create the same loop, but for this one is to find the index of the last occurrence of this maximum element. How we will do that? We should let I, it will be the same in it everything here. But one minute, I guess I it will equals 1 because min index 0, so we are starting at the 0. So I will equals 1. It will be better idea and start instead of I equals 0. So I will be less than n, and I will be plus plus. I would say if nums of I bigger than nums of max index, that means we have a bigger number, so max index will equals I. And right now we have the we identify the min index and the max index. Right now we need to calculate the swaps, or calculate the total number of swaps needed. How we will do that? Let's create a variable called swaps. And in this variable, I will try to do this one. How can we know the number is working? So it's basically there is a formula for that. The minimum swaps, it will be equals the min index plus n, which is the nums.length, minus 1 minus the max index. Okay, let's try to discuss this, and let's try to discuss in detail. So let's talk about the calculating the required swaps. So to bring the smallest element to the leftmost position, we need as many swap as it's in its current index. For example, if it's at index 3, it's need 3 swaps. So for example, in this one is at index, I guess 6, so we need about 6 swaps. Okay, and to bring the largest element to the rightmost position, we need as many swaps as a distance from its current index to the last index. For example, if it's at index 3, we need to, let's say that 5 here, so we need to know which one. So basically, how many swaps? We can say it's only 2, but how we can calculate that? It will be the length of the array minus the current index minus 1 to know how many swaps do we have. So by this one we can return and it will work. But however, if the smallest elements in the index, which is min index, is greater than the largest elements, which is max index, one of the swaps can be saved, because moving one element can particularly help move the other. So I wanna say this: if the min index is bigger than max index, if that was the case, I would say the swaps would be minus equal 1. So in this one, if the smallest element is to the rightmost, to the right of the largest element, we save on the swaps, and after that we return the swap. Okay, let's try to discuss this again. So here, if the smallest element, its index min index is greater than the largest element's index, which is max index, one of the swaps can be saved because moving one element can particularly help move the other. So let's try to look at this again. So let's walk through the example step by step. Let's say that we have this as an example here, as an array. So if we want to find the indices, we will find 5 and 1. So the smallest element, it will be at index 5. And so this min index will be at index 5, and largest element, it will be at index 3, because this is the largest one, or this also can be. So the largest element, it will be at index 3. So we need to calculate the swap. So we move one to the front of to the front. It will take 5 swaps because min is 5. So the swaps here, it will be it will take 5 swaps, and move 5 to the end. It will take 2 swaps because we have 5 here. We 1, 2, and if we need to move 1, it will be 1, 2, 3, 4, 5. So we have 2 and 5. So swaps, it equals 6. It will equal 7. But we have adjustment. So we have to do some adjust for overlap. So since min index is 5, which is bigger than max index, we save one swap because they will swap each other. So we take 1 from it, and it will equal 6, as you can see in this example. So yeah, that's it. Let's submit it first to make sure if it's work or not. It doesn't work, and I don't know why. It doesn't look good. Let me see how it didn't work. So let's see. So swaps will equals min index n minus 1 minus max index. And if min index bigger than max index, we will take 1 from swaps and we return swaps. And here in the 4 we have let I equals or equals, sorry. Yeah, it works. So yeah, that's it for this one, and yeah, see you in the future.